me? Yes, we have. Thank you so much, Steffi. It's such a pleasure to be here. Everyone, my name is Zina, and I'm going to be your guide today in this fantastic voyage we're about to take. By background, I'm a condensed matter physicist, and these days what I look at is the frontiers of technologies and their impact on our societies and cities and citizens. And one of the areas, one of the most exciting areas that is opening up in front of us as we speak is this superimposition and superposition of AI, machine learning, quantum, and health. And what we are doing right now is that we are extremely lucky because with us we have on this stage some of the thought leaders that are going to be representing vision, reality, pragmatism, and they're going to be leading us in this conversation. So without further ado, I'm going to take you on a journey, and we're going to start with our first question, which is, for all of you and for each of you, I would like to get your understanding and vision of what does the combination of these three, health, AI, machine learning, and quantum mean? And could we start with you, Jim?
Well, I will, and again, it's such a genuine pleasure to be back here at DLD. One of the special conferences, I think, that have more than improved and excelled over time, which is a real joy, and Steffi and the Berta team deserve great credit. I'm a venture capital investor, and so my job is to try to see around corners that exist 3 years from now, 5 years from now, and identify deeply promising technologies that are going to make a very significant difference in the world. And why quantum and AI are so important right now is, in a breathtaking way, they together are transforming very specific verticals as we speak. I'll talk more about it. The worlds of medicine, healthcare is one example. If I could speak to a 28-year-old venture capitalist candidate, I would say dive deep. Make this your career. Have linear math background, electrical engineering background, humanistic background. The next decade will be filled with startups achieving scale across these interdisciplinary areas.
That is so exciting, and I think, Jack, could you lead us on a little bit further into some of those examples as well?
It's great to be back here. Thank you, Steffi, Yossi, for having us. Great to be friends of DLD and to have this incredible audience. So many people who are changing the world in one place. Okay, a lot of pictures too, good. I would really say two things to build on what Jim talked about, which is simulation and sensing. A lot of times when we talk about quantum, you hear about quantum computers, and quantum computers are critical. They're going to change our world, but they're a number of years away. Today, though, right now, we have technologies in front of us from quantum, the quantum ecosystem, that apply to healthcare, and you need AI to make them happen. I'll talk about simulation first, then sensing. Simulation. When we have a molecule that meets another molecule, the language they speak is quantum. They don't speak German, they don't speak English, they speak quantum. And the ability of those two molecules, and for us to understand and simulate that billions of times in a computer, was once thought to be in the year 2030, 2040. What we and others have now demonstrated, Zani, is that we can do it now. We can do it on GPUs, we'll talk later about that. And now, by doing so, we can really shorten the time that we can develop and discover drugs. Sensing. People have not heard about these quantum sensors. We make them from diamonds, not diamonds from the ground, but diamonds that we create right here on land. Diamonds that we manipulate in ways that give us sensing of our heart. And right now in clinical trial, there are quantum sensors made of diamonds that are detecting not the electric field of our heart, not ECG, but the magnetic field of our heart, MCG, magnetocardiography. This gives us richer information. Heart disease is still the #1 killer in the world today. We don't have good enough diagnostic tools to make this happen. But these are so sensitive that we need AI to pull the signal out because they sense everything around them. So it's really it's the AI, it's the quantum coming together. These two coming together, and I just want to underscore what Jim said, this is the time for a deep dive by venture, by industrial giants. We'll probably hear from Niko on that, where he works with the largest corporates. This is the time to double down. Not years from now, but right now.
I love that answer, and especially the fact that you mentioned it's the superposition of these two areas coming together at the right time to give us this ability. Niko, could you guide us from the McKinsey perspective?
Yeah, you know, besides the fact that those two areas are coming together in the two main quantum areas, like sensing and computing, the main question which comes to us is always, what is actually the industry which is most affected by quantum computing, by quantum technologies? And when we did the analysis, 4 industries came up, and one which ended up on top of it was pharmaceuticals. So that's exactly what Jack just said, and Jim as well. So the impact quantum computing could have and quantum sensing could have in the pharmaceutical industries is amazing. And the number we came up with in terms of industry value to be created is in the range of 1 to 2 to 3 trillion US dollars. So it's an amazing amount of industry value which could be created.
Those are very promising numbers, but now I want to take it a little bit further, and I want to challenge you, and I'm going to start with Jim, on possibility, feasibility, and timeline. Can you guide us through where we are?
Well, I'll give you a sense of where things are. I came initially to this field of where AI meets medicine in 2016. I was on the Harvard Corporation, the senior governing board of Harvard, and President Drew Faust asked me to be point person on the new search for a dean of the medical school. I ended up interviewing around 30 individuals from around the world, phenomenal people who were finalists and semifinalists. There was not one candidate in 2016 when I asked her or him about the impact of AI on medicine, not one was able to give an articulate answer. This is only 7 years ago. We ended up with a phenomenal dean at Harvard Medical School, George Daly. But dialing forward in terms of timing, I spent a year spinning out a team in computational pathology from Memorial Sloan Kettering in New York to focus on prostate and breast cancer. It took me 9 months to negotiate the deal with the trustees and the institution. And the company Page AI has a number of FDA emergency grants, et cetera. The outgoing CEO of Memorial Sloan Kettering spoke with me about 3 months ago. And he's, in one of those rare cases, said, Jim, you were absolutely right. I never thought that this would happen in the world of medicine and academic hospitals as quickly as it's happening. And what he said is 10% of the professional staff at Memorial Sloan Kettering today has computing or computation backgrounds. He believes that number is going to be 80 to 90% by 2030. That just gives you an idea of, even at our most traditional but our very best worldwide medical centers and universities, how quickly these silos are being broken and how quickly this will happen.
I very much appreciate that perspective from that angle. And I think, Jack, would you be able to lead us on around the industry perspective, timeline, feasibility, and reality?
Anyway, I think what's very interesting is that when we look at the business press, the popular press around quantum, it's been very focused on one thing: the building of quantum computers, a horse race. How many qubits do you have? How many qubits do you have? And it's interesting, and it's nice to see that horse race happening. But the bigger picture is that the quantum equations that govern life sciences, we could run today on the GPUs of today, the chips that initially were there for video games. So anytime you see a teenager playing video games, thank that teenager. Because of their video games, we have deep learning and AI, and now we have simulation. on GPUs. It all came from the G in GPU, graphics. But now, of course, we've moved that to these other areas. So the feasibility actually is running it on classical hardware. Once quantum hardware rises up and gets fault tolerant, we will mesh that together. The future of computing is not quantum or classical. It's a mesh of these two.
Yeah, I think we are absolutely talking about a hybrid architecture. Yeah, so we will see high-performance computers working hand in hand with quantum computers. Yeah, but in the end, when it comes to the timeline, and I'm probably the most pessimistic one here in our round, and we had the discussion before. You know, from a simulation perspective, we can do a lot already. That's absolutely correct. But if you just think about, you know, simulating a very basic molecule, it takes you about 150 to 250 logical qubits. Yeah, at the moment we have about 200 to 300 physical qubits, and we need in the range of maybe 2 million physical qubits to produce the 200 logical qubits. So there is still a way to go, but I think the future is there. Yeah, it's coming. It's just a question of time.
I like that perspective, especially we covered it yesterday with Marcus Flitch from Terra Quantum and this hybrid approach. It is not a matter of us waiting years and years until we have the quantum supremacy and quantum computers. But I would want to now ask an unusual, perhaps, question. I want to start with you, Jim, obviously, as a legendary investor who has led with vision. Hypothetical scenario, you have $1 billion to spend on a single technology in 2023, and you're not driven by return on investment. You're only driven by vision and the big, big picture impact. Where would you put your money?
Well, I'm always influenced by return on investment. It's my nature. I love what I do, and very, very competitive about generating what I always hope are very superior returns.
I'm challenging you, though.
But taking that off the table, $1 billion is needed. If we think again, going back, just pick cancer and AI, where the fields have not merged in terms of the research and how they have come together. $1 billion invested in cancer and AI solutions with the world's best doctors, developers out of Google and Facebook, different entrepreneurial teams, will pay off enormously, whether it's for-profit, non-profit, hybrid models, in 10 years. This is an area where, again, the skill sets that are required to solve the problems of Alzheimer's, of prostate cancer, of cardiology, the skill sets are physics, linear algebra, computer programming, biology, neuroscience. And so part of our job as investors and board members, pull these skills together so that the 28-year-old out of Alphabet, who is a world-class programmer, isn't pointing fingers to the 50-year-old scientist out of Harvard Medical School saying, "You're just moving too slowly." That happened this week in one of my meetings. So that's the ongoing challenge, but my goodness, it's breathtaking. I lost 2 parents to cancer in the last 5 years. Given where we're headed, we could have extended each of their lives many, many years with the technologies that are being invented and deployed today.
That is so enlightening. And I would love to hear from you, Jack. Okay, you got $1 billion. Not driven by profit. Go.
If I had $1 billion without thinking about return, but it turns out this investment will give the best return, it is on 2 programs, university programs and training of adults who are already working in the field. $1 billion would help us create the workforce of the future. The fact is, right now, we have a massive supply-demand imbalance already. We all know in this room about the supply-demand imbalance in AI. It's getting already worse in quantum. Already the amount of funding that has come in due to Jim and others has funded up these wonderful companies. But what is most of that funding going to? It's going to hire great people. We don't produce enough people in the space yet. And so an investment not only in PhD, master's, postdoc, but also in the current workforce. The current workforce is much larger than the number of people going into PhDs. So it's the upskilling of those people who might be in the semiconductor industry, who might be in the healthcare field, who might be in other fields, and bringing them up to speed. That is one of the best investments we can make right now.
That was not the answer I was expecting, but now I know a lot more, which is exciting. So Niko, tell us, where would you put your money?
Or maybe I would buy a plane and a Ferrari. No, I would quite honestly, I would invest in the intersection between quantum AI and pharmaceuticals, because I'm a strong believer of material design in that space. And material design is a lot more than just materials. It also includes truck design. And if we are able to crack that code, we will change the world. We are able to change the world, and we will build a completely new future when it comes to any kind of health problem. And you mentioned it, Jim, yeah? So this is, in my perspective, one of the most promising area to invest in. So that would be my...
Fantastic. You know that as a material scientist, that is music to my ears. I truly believe that with the addition of these technologies and the exponential development, we're going to have mastery over matter and material design. And that is going to change the way that we interact with our bodies, with our car designs. Can I touch on that with a few examples, if I could? Jack, could you give us a few examples of what that means?
Well, Zina, just to build on what you're saying, you talked about the metaverse. You talk about that a lot.
Yes, I talk about metaverse, Arden. That's metaverse, matterverse, atoms and molecules.
And another way to say that is bits and atoms. I would give the tech sector overall pretty high marks on the bit side of the coin. That is, we know how to transport bits, store bits, secure bits, make new bits, have AI that is bit-based, analyze other bits for pattern recognition. I would give us a failing grade as a tech sector in the world of atoms in the metaverse.
Absolutely.
We have not given the tools to the pharma industry, right? As Niko and Jim were mentioning before, we're still taking 13 years, 2 billion euro on average to make one drug. And after all that, 2/3 failure rate in clinical trial. So we, the tech sector, have not given them the tools to increase probability of success. Let's talk about battery chemistry. 30 years on in terms of electric vehicle development, we're still using what chemistry today? Lithium-ion chemistry. It is not scalable to the billion electric vehicles that we need on this planet. Lithium, for a number of supply chain issues and other issues, we cannot scale it. We need novel chemistries. The chemistries, there's an understanding of the landscape, but we need multiple billions of permutations using hybrid computing to make this happen. The simulation that we talked about before, the material design that Niko just mentioned. So battery chemistry, automotive and aerospace, finding materials that are as strong as the ones today, but are lighter so that that same battery can take that vehicle twice as far in terms of range. These are material design issues that we can change using the tech tools that now are in development. So yes, high score for the tech sector on bits. I would give us a failing score, though, on the metaverse. And that's what we have to change right now. That's the urgency. We have become complacent. If we said, Zani, that we're going to build another building here in Munich, we're going to hire a construction company, there's a 65% chance it will fall down in the first 30 days. Would we accept this in the construction? No. But this is what we accept in the world of battery chemistry, in the world of pharma, and so on and so forth. We can now change that using advanced computing, using AI and quantum coming together.
And maybe to add one point to this, and to give you a couple of numbers here, there's also a need for change from the cost perspective. Currently, in 2020, the pharmaceutical industry, beside taking out China, but the rest of the world, spent in the range of $200 billion in truck discovery, R&D of new trucks and everything, with decreasing ROI over the last 25 years. So if we continue that path, that will go nowhere. So we need to change something. And just the impact, if we are able to bring up quantum computing power into that process, that will, just for truck discovery, unlock in the range between 60 to 80 billion euros out of the 200 billion which are invested. So the impact is huge, and that's just about drug discovery.
Jim, I'm going to end that question, and I'm going to go to you first. Okay, so I want to ask an unusual question, and I want to ask you to give us a gift and a favor for us, to the audience here at DLD. Give us an insider tip. Give us that information you wouldn't tell anybody in public. Give us that information that you would only share behind the closed doors at a dinner with your confidant friends. Can you tell us something? And we all promise we will not share this anywhere else.
Yeah, exactly. We're among friends. I'm going to answer it in two parts. First, for me, moments for reflection are unfortunately too rare. And it was exactly 3 years ago at the World Economic Forum in the Hotel Belvedere, late at night, drinking wine with Jack.
At the bar.
At the bar, where he came up with the idea of Sandbox, and I shook his hand and said, I would love to be your investor partner. And that's 3 years ago this week. The insider tip really is around skill sets. Educate ourselves, our children, grandchildren, in a variety of different fields, because it is all about interdisciplinary. My first boss when I was at Stanford was an individual named Steve Jobs. He was the original interdisciplinary genius. And that's the kind of genius and sets of skills we need if we're going to effectively tackle areas like quantum AI as they deeply impact medicine.
Such a great answer, and that was an insider tip for you guys. Jack, what would be your insider tip?
Well, first of all, the first lesson is go to bars late at night, because you never know what's going to happen. I'm serious.
Ooh, for tonight. That was a tip for tonight.
That's first tip. Inspired by The Graduate, people remember the scene in The Graduate. The word at that time was?
Plastic.
Yes. The word I would give you now is GPUs. GPUs, if you think about DALL-E 2, if you think about GPT, how many people have played with DALL-E, GPT? Everyone's loving it, everyone's loving it. Well, the story behind the story of these wonderful, incredible innovations, and AlphaFold, and all the things that we've heard about, are the chips. 5 years ago, we couldn't make these layered networks because we didn't have the computing power. But this incredible healthy competition of NVIDIA, of Alphabet's chip area, of Amazon's chip group, of Tesla with their D1, of GraphCore at their IPU, of Intel and AMD, of startups that you haven't even heard of, Halo out of Israel, a chip startup company that many people have not yet heard about but will very soon. This intense competition has given all of us in this room incredible, wondrous capabilities that now we tap into, known as DALL-E, known as GPT, known as Bloom, known as the other Palm and Lambda and others. It's this underlying architecture and this healthy competition that has given us these incredible developments. So if I had one word, I would say check out the chips behind the story, GPUs.
I love that, interdisciplinary and GPU. So now, Niko, you go.
Yeah, my tip is just invest in talent. Yeah, because this is, and Jim, you mentioned it as well, interdisciplinary talent, whatever it takes. Without talented people, we will go nowhere. Yeah, we can talk about quantum computing, but we will never make it. So far, we can learn the lesson out of the times when AI came up. So we did it wrong. Then after a while, we corrected it and we did it right, or we got it right now. But in the end, it is all about talented people. And I can tell you, the talent gap in quantum computing, quantum sensing is already huge. Yeah, we did the calculation on people needs based on job offers which are out in the market. And the job offers out in the market are in the range of 800,000 to 1 million. And the talent gap is already in the range of 300 to 400 people. So it is growing every year. So my tip is invest in talent. That's
That is a fantastic and very much human-centric message that you have. And with that, I would like to thank the thought leaders on our stage. I would like to thank you. And I would like to close with this one thing. The future is unknown. And especially with the exponential development of technologies and frontier technologies like AI, like quantum, like machine learning, there is going to be a lot of excitement, and there are going to be a lot of uncertainties ahead of us. But as long as we have action and thought leaders such as you guys, who are candid and who are optimistic about the future and who are open to challenging themselves and the ideas, I am extremely and immensely optimistic about our collective future with frontier tech. Thank you so much all for joining us in this conversation.
Thank you, Zani.
A round of applause.